welcome to this Telit Cinterion webinar, How to Secure IoT for Public Safety in Smart Cities. I'm Amanda Flink, the Head of Global Events here at Telit, and I will be moderating our discussion today. Let's quickly get to know our speakers. To explain this topic today, I'm pleased to be joined by two speakers. First, we have Enrico Marini, Software Product Management at Telit Cinterion. And second, Steve Measure, Director of Government Sales at Digi. Now, just before I hand it over to Enrico to start our presentation, I do have a few quick reminders for our audience. We will have time to answer some questions at the end of our presentation. You can simply submit a question by posting in the questions box located near the bottom of your screen. Also, please be sure to check out the resources section for some additional information on today's topic. There you can find today's slide deck and some other resources from both Telit and Digi. And finally, we will send out the replay link to attendees at the conclusion of this webinar. And with that, Enrico, I will hand it over to you to start our presentation.
Thank you. So, hi everyone. My name is Enrico Maronjo. I'm an Italian guy working for Telit Cinterion. Telit Cinterion, as you may know, is a pioneer in end-to-end communication. Today, the company is widely recognized as the leading enabler of the Internet of Things, also given the recent news and merger and acquisition. Telit Cinterion has always been at the core of the Internet of Things, even when it was end-to-end. Basically machine to machine. And now we offer products and services for companies, large and small, that basically rely on mission critical connectivity with an accent on security, and they're really concerned about the scalability and enterprise grade performance. So we cover a range of products and services that are interconnected into solutions. Telit Cinterion IoT module products and IoT connectivity and platform services basically enable end-to-end IoT deployments, and from things to apps. So you can use our modules or our connectivity or our platforms separately, or you can bundle together for a much better experience and integrated end-to-end solution, basically. So you can reduce the complexity, the risk, the time to market or time to revenue, depends on how you feel that. And of course, costs will be cut down, and you can start nimble and you can grow with us, basically. In one word, we offer the hyper connectivity. Steve, please.
Thank you, Enrico. My name is Steve Measure. As Amanda mentioned, introducing Digi very quickly. We're a communications manufacturer based out of the Minneapolis area. We've been in business almost 40 years, and just this summer we passed the market share of 1 billion market cap. We are well known for our industrial hardware. The company originally was built around those markets. We've expanded as well into transportation and transit and many things in that market, as well as in the enterprise space. While our hardware is always considered one of the most reliable, we're also very good at software, and that's become one of our differentiators with our management applications as well as our embedded Linux platform.
Okay, so this is let's say an old citation that happens to come here and there, but it's still relevant. So according to Juniper research that comes in 2015, smart cities may see up to a 15% improvement in emergency response times and 10% reduction in violent crime. So it seems to be a really great achievement if we can have smart cities. But where we are after 5 years, that's the big question. And unfortunately, we can say, because we live in a really highly connected world, that not all cities are become smart. Some perhaps are even dumber, I would say. The point is that the becoming a smart city requires a huge effort and a big digital transformation. And the recent events, also the pandemic, somehow helped this. But we're still back in behind in schedule, even for the most advanced countries. We have huge problem in developing a digital transformation plan, and the point is that we really need this because with a better city, we have better life and safer life, and it's really time to make it happen. The point is that we need to start with a infrastructure basically, and the infrastructure is the enabling one that allows smart city planners to build everything that is needed, not only for public safety, of course, but let's focus on this for now. And just consider the fact that with smart buildings are properly equipped with cameras, sensors, uh, you have the possibility to do a post-mortem, let's say, of what happened in accidents or incident of any type that involves people and properties. And of course, you can have also live video or and audio of what's happening. So it's great advantage with respect to just sending, let's say, a response incident response teams after the event happened. The same for smart traffic signals. What happens if you have a big accident in the highway and you need to send ambulances or the um, fire workers? Of course, the dumb traffic signals are not capable of reacting uh, to these events. So we need sirens, and we need to trust people in the streets to let them go and pass. With smart traffic signals, you actually have the possibility to drive and to divert the traffic to different places to allow for a smoother emergency response. And the same is happens when you have smart vehicles that can connect and then give you information on the traffic and on the situation in the field, in the real field. Last but not least, smart street lights. We know that smart lighting is preventing uh, accidents and is increasing the safety for the population by just providing a better lighting situation. So it really needs a bulb to feel to have you feel safer. The point is that we need to connect all these things together. So we cannot run these things in a disconnected way because smart street lights, of course, they have their own systems. So is the smart building. So we need to make sure that when we need to think about safety, we need to think in an interconnected and harmonized way of getting the information, both for monitoring and control, but also for prevention. And so the point is that the keyword, let's say, is connection, interconnection. And so having a smart city means having a thoroughly connected city. So interconnection is not only the from infrastructure perspective, but also from service perspective. So um, the various actors and the various systems need to cooperate and to provide information um, in a harmonized way. Uh, so as smart city planners, we need to think available by design, of course, because the infrastructure must be available in every condition. So we need to build a resilient IoT network. The network must comprise multiple technologies, of course, for different use cases. Now we know we have the fiber optics, we have the copper, we have Wi-Fi, other short range, unlicensed spectrum, and of course we have cellular. Well, Telit Cinterion is pretty expert at cellular. Also in the cellular, we have different technologies depending on the use case that you want to implement. So we need to make sure that all these technologies work together and the messaging is routed in a proper way. And considering the complexity and the high number of connected devices, we have another risk. We risk to get lost in inventorying all these devices that connect to the network, to the smart city system. Just think about little devices that provide information on the smart lights. You can have hundreds of thousands of them. Or think about the gas metering or the water metering. How many appliances do you have? Uh, think about big cities like in New York City, you have hundreds of millions of them. So it's really difficult to manage, to properly manage all the data that comes from these devices and manage the devices themselves if you don't have a proper identity for each of those devices and sensors. So identity is the other key word in a highly connected city. Uh, and of course, this is from the technical standpoint, but we need to consider the governance part. So municipalities need several actors that should be involved in the development of the smart cities. Um, so contractors, operators, government bodies, a variety of stakeholders that could utilize the resources that are provided in the smart city infrastructure. Um, so what we really need is basically how we can ensure that this really happens. Sorry, uh, in the easiest way possible. The point is that we need to consider multi-factor deployment. So if every single service has its own timeline, and we need to coordinate all these steps. And we have a plethora of services that need to be coordinated. At the end, the information flows, whether it's sensor data or data patterns or alarms or supervised or unsupervised actions, considering also, artificial intelligence, a big buzzword in these times, but really useful technology. All of them require a comprehensive and diverse connectivity coverage and require different, have basically different requirements, and they cover different use cases. Um, so the other important thing here is how I can have a sustainable smart city, because we have seen a lot of projects, government projects starting and then dying after a few years because there was no funding for sustaining those projects. So we need to make sure that these projects really work and they are self-sustainable. So there are new revenue streams that we need to consider when building a smart city. And a smart city means a lot of data, a lot of information, a lot of new services that can be provided for citizens. And we need intermediate actors that take care of this, not directly from the government, but they need to be licensed by the municipalities to give these kind of services. So let's go, let's say, a bit deeper in the, let's say, sphere of influence of enabling smart cities. Let's start with the actual services that we provide. So we have, I would say that we can run a smart city application bingo. You can name, uh, just to name a few. We have the smart waste management. We have the EV charging station, or the uh, smart mobility, and of course, staying on the safety, on the public safety, we have the security and safety cameras, but also we have systems for social inclusion and management of the situations that elderly and disabled citizens come across when living in the city. So even people tracking is part of the smart city big plan. The point is that when we deliver these services, as I said, we need to consider several competencies in the plate. So for sure, we need to make sure that the services are mission critical, so they can run in any condition. And this means that we need to think security at scale for really large deployments and really highly interconnected devices. Um, we need, of course, to provide both the development plan and the maintenance plan according to the actual capacity that we have in the city. So the challenges that we have here is that we need to run different projects at different paces with different actors in different times, with potential collisions as well, or dependencies. and we need to make sure that all the synergies that we thought in advance are really creating the benefit. When we go on the let's say outer range and we think about the operations, now we have the business intelligence layer. So the services are there, they are providing a huge amount of information, and we need to gather this data and understand it. So here comes at play uh, various system integrators and information experts that are able to provide all the services and the platforms and the processes to actually mangle on this huge amount of data and provide meaningful information, something that is really useful for the city, for the citizens. And of course, real-time traffic monitoring is the easiest way that you can think of, but also geofencing application for convicted people or elderly people as well, so you can get an alarm when they cross a specific border or neighbor without having heavy bracelets or something like that. Then you have also from the utility side, you have the utility grid and waste management systems that need to be monitored, and they are easy, let's say, fruits for terrorists or malicious attackers, because we have several events that may happen, and not all of them are natural disasters. In here, of course, we need to plan uh, um, um, a rolling wave of updates for all these platforms and all the data that we collect. The point is, as usual, we have the cycle, the plan, we do, then we check, and then we act. So we need to put in place several countermeasures when we enable a smart city. So it's not something that you can do in few months. It's going to take years, and we need to evolve all the services and the technologies that are deployed to according to the real needs of the services. And of course, let's not forget about decommissioning. Sometimes we forget about technologies that we leave there, and they are called zombie IoT networks. And there are several examples of people getting control back, getting back in control of these networks. Um, so this is the outer layer of everything, and basically we're talking about the end services that go to the citizenship, and we have open data, of course, a big word here. We have e-democracy, we have social inclusion, we have digital divide bridging, and we know that all these actions at the end have an impact in the public safety. It's also a preventative action for specific cases that arise and happen only when there are specific situations in the social texture, let's say. So here the competencies are basically governance. So we are at the higher level of the smart city governance, of course, and management. And here we need to make sure that the multi-vendor approach, the multi-provider, and the multi-technology is something that we can really harmonize. To harmonize this, you need really competent and expert people in their fields, of course, and people that can actually play in a team to provide the best possible outcome based on what is the objective of the planner, of course. And when I speak about the planner, I'm speaking about the mayor and the government, basically. Of course, the challenges here are high. For instance, even writing requirements on security is high. So that's why Telit, Cinterion, and DG and other partners are really helping in this. And speaking of which, Steve, I know that you have a success story to tell here.
Thank you, Enrico. A great example of an IoT system in a city, of course, is traffic management. And in New York City, they deployed 14,000 routers, one at every intersection. So why would you go to that level of communication? Well, what is a traffic system is critical these days, because how do you improve the throughput of vehicles and people and provide safe travel for passengers, for pedestrians, bicyclists, and such? You automate these systems and bring in sensor networks to help. And with a good traffic communications network, you can really improve the flow of traffic. And not only just the flow, you can also monitor and see what improvements have done. For example, in the intersection, there's a sensor there which is tracking the anonymized information such as a MAC address. So a vehicle that travels through the city is tracked, right? And the flow then, if you look at that holistically, you can see whether a particular improvement you made or light timing change actually benefited the flow of traffic to the city. So it's quite a system, and for New York, which is really deemed critical infrastructure, right? Because of the the functions of the city, the critical businesses there, as well as all the international entities. That's become quite a nice project for them as they continue to manage the city. So we'll look at some of the details there in the next few slides on how this IoT system operates. Critical, of course, as mentioned, is the communications network. This system has to stay up. Those intersections need to stay connected. That's the only way you can automate and adjust to traffic flows and congestion to make sure everything's moving through as best possible. And that's done by really carefully managing each link. This diagram shows some of that. There's an IPsec VPN that carries all the traffic for security, and that VPN is moved from across different wide area network links, and the system automatically determines which link is best. And if the least cost link is running well, then of course that's where the IPsec VPN stays. Once there's trouble, it moves, and that trouble is detected using probes. The probes, of course, travel back and forth between the two systems, and you measure the latency, and if the latency is going up, you know there's trouble, or if the probe doesn't return, then that's an indication the link might be down. So this is how the system operates. And also, part of that is the detection, right, of the traffic control center itself. Perhaps there's trouble there, a power outage. The system can shift to a backup control center. A very important part of the system is the security, and they run a very high level of encryption there. It's AES-256, and that's done through what's called dial-up VPN. All the routers are remote, and they dial in through. They run IPsec VPN tunnels into a concentrator there, which is really a next-generation firewall with intrusion protection systems involved. On the other side there's an encrypted tunnel out to the management platform called the Remote Manager. Important part of security is authentication, and if you're familiar with public key and infrastructure, that is the best way one can authenticate because it's very secure. If there's ever any trouble, the systems are designed such that certificates can be revoked. So if there's any threat, any thought something has been compromised, it's very quick ability to deactivate that system, and it can no longer access any of the critical infrastructure of the network. And but certificates are very difficult to manage. They expire, right? And they expire at the worst time when you least expect it. And you can imagine for 14,000 sites, you have to automate that. Unfortunately, there's a protocol called SCEP, Secure Certificate Enrollment Protocol. It's been part of the Internet standard for years. It's automating all of the certificates from their initial enrollment to their renewal, right? As is critically important because you do not want them to expire. Your network can go down. So this is all automated in New York City and provides for a really seamless part of the security framework in the traffic network. Also critical is how the system is structured and the operations of it in regard to the management of the devices. In this diagram, the operations of the network you can see is there. It's critical. It's on its own. Adjunct to it is the management platform. In this case, runs on Amazon Web Services. Should there be any trouble with Amazon or the internet, of course, very rare, but if there was, it would not impact the operation of the system. It's still up and running. What happens across that link is performance data goes in one direction, and in the other direction, there's configurations and such that help to manage such a large network. And it's done quite effectively. These systems today make sure that, and we'll go through a little bit more how things are automated so that you don't need that many people to really run these networks effectively. In fact, in New York City, there's not many folks running 14,000 networks. It's quite remarkable and nice to see. Moving on to another IoT example, it's in public safety and for vehicles now, for public safety, for police cars mostly, but anyone in law enforcement, that connectivity is also critical. You can imagine these days as you access criminal justice information system databases, license plates, it's a real-time communication link needed from the vehicle back to the command center and control. One of the trends these days is what they call real-time command centers, where multiple jurisdictions may be involved in the incident, and therefore, how do you coordinate all that? It's done through these control centers and through really good communications, because it's not just accessing databases, but also real-time video now is part of these systems, so they can really move fast and help and keep officers safe and out of trouble. You really use the latest technology with these, both 5G and Wi-Fi 6. And one other important aspect to this is extended range of communication. Sometimes in perhaps more rural areas, your cell towers might not reach. Well, there's a feature now as part of Band 14 in FirstNet called Mega Range, and there you can have a much higher power transmission from the vehicle, so you can get to those extended ranges, perhaps out on the countryside. Another important part of that is a mobile VPN by radio IP. As these vehicles travel, they're moving between cell towers. They to keep those network links up and persistent across the multiple jurisdictions. This technology from radio IP really helps to maintain those links and keep them secure. Just highlighting three key areas of that. The Trust Fence is a framework for security that provides for some critical areas on a router, right? Secure boot. You want to be sure that what code you're running is actually the code that was downloaded. There's also digitally signed firmware, so that when firmware is uploaded to the device, that it's ensured that it is actually coming from the manufacturer. There's all sorts of password control. There's a cryptographic coprocessor on board that keeps keys safe and secure. They're not even visible to the network administrator. Another key area is FIPS 140. That's a federal standard for information processing. If you haven't heard of it, it provides for validated cryptography. And that's very important because you want to be sure that all those encryptions and authentications that are done in a standard way. There isn't any deviation from what is known. You do not want to create a security hole, and the federal government validates these through their National Institute of Standards and Technology, NIST, with this FIPS 140 validation. And then also, as I mentioned earlier, CGIS compliant mobile VPN is a key part of that solution to maintain secure connectivity as the vehicles travel.
So I think that we have seen a great example of how we can guarantee public safety. And now the point is, how can I hack this public safety system? Well, there are a lot of systems, and where should I attack them? The point is that basically a hacker's mind is set to find the loopholes. So if you don't design the solution with security in mind, you're exposing many more loopholes, of course, and be sure that the hacker is getting a finger in all of them. The point is also that hacking a system is a matter of budget and motivation. So if you're a terrorist, you may have a really high motivation, perhaps even higher budget to attempt everything. So there are different security countermeasures that you can take into account, but for sure you need to think in such a way that your systems are protected. Now the point is that Rome wasn't built in a day, so as your IoT project, you have legacy to consider. You must cope with heterogeneity and transitions, technological transitions, and you must execute, check, and adapt, and deploy new pieces and decommission the old ones because they can be the real threat. The point is that the hardware is the preferred attack surface. And we've seen a lot of examples also with cars. You can unlock a car now with wirelessly in a much easier way and fashion with respect to the old cars, the old 1970 cars where you needed some piece of hardware. Now you need a Bluetooth a speaker, and you can open several several brands altogether. So the point is that the device, the IoT device, is opening a path and a threat, a breach for accessing the system. And the point is that the system is not only the IoT device, but the IoT solution, and the IoT solution comprises different layers of interfacing the solution. So you start with the physical devices, then you have the edge computing, you have the connectivity. So you have, for instance, the SIM data plan or the IP protocol. Then where you collected the data, where you do the rationalization, and you put the business intelligence basically there, and then all the systems that you put together to integrate all this information in one place basically, or in multiple places, but in a harmonized way. So the real point here is that with the massive IoT happening, the threat landscape is drastically and dramatically changing. And Steve, I think that you have some words here.
Well, thank you. Yes, and Enrico. So, as you've seen, and that operational systems that we have had for decades across America, across the world, right? These are now getting connected into IT systems, and whereas once they were isolated and separate, that air gap now is gone, and everyone is out busy taking advantage of what IoT brings, and it's a wonderful transition. You get efficiencies, you get better performance, and overall the system operates better and provides much better service to the users. But that comes with risk, and so as we've been speaking today, right? How do you guarantee that you don't get hacked? These information technologies now and deployed in operational systems have to be secure. We've provided some of those methods here today, but cybersecurity systems are quite secure, and they just need to be implemented across these operational systems to keep them secure. And related to that is automation, and automation is critical now, and one that perhaps people don't think about, but it's happening, and it's for good reason. The number one driver for automation is really security. The second one, interestingly, is just that automation helps improve the network resilience. And unfortunately, that's because humans, right, are often the cause of network downtime. Some mistakes are made, and the network is brought down. So automation helps the network resilience. And then also, as far as just removing the need for repetitive tasks, sometimes networks have to update firmware, for example. How could you do that to 14,000 sites? You need to be able to push a button, and out goes the firmware, and it's all automated. Otherwise, it would just take too many people, and there'd be too many errors. But back to security, what's happened in the security side is that when you have automation, that improves the reliability. And when a network has good reliability, it's very predictable. Every day it's operating the same, right? You can see that. And where that plays in security is when there's an anomaly, it's more apparent because of the predictability of the network. And so it's a feedback loop, and where you now have automation driving reliability, driving predictability, that then becomes a driver for security, because you can see when things are now working out of place. And so it's just a critical area for networks to automate everything.
Now the point is, what happens if smart cities are compromised, or even one of the systems is compromised. As we have seen, from one single device, we can access theoretically a huge number of systems and information that could be sensitive, that for sure is confidential, and this could cause big issues. Now, let's just think about what's going to happen if you use smart meters for, I don't know, your gas system or your water system that are not built with security in mind. You can create huge outages. So it's really key to make sure that the device is all the components that you put in your final hardware application that then connects to the system are resilient, they are untamperable, they are available, and they are confidential. This means that the devices, also the smaller ones, the tiniest ones, need to be identified, need to be secure in by all means. And this is where also Telit Cinterion is working with the modems and the Wi-Fi modules. So basically, governments are moving here and putting several requirements and several standards that basically recall the best practices of cybersecurity, but with a huge problem. The problem is that there are so many standards and so many regulatory bodies for security that it's really difficult to follow all of them. So FIPS, for instance, is a great standard, but it's let's say US based. There are other countries adopting it, but this is not mandatory for anyone basically outside the US. Um, Steve, I don't know if you want to chime in about cybersecurity best practices.
Sure. Yeah, just a few words. I think where we've seen trouble with some of our customer networks or where things are too complex, you want to have a common configuration, for example, for all your devices, and keep firmware updated. That's obvious. There's critical vulnerability lists that are published whenever there's notification of trouble. Boy, get that out to there. And so you have to have easy to use automated firmware development systems. That's about it, Enrico. Thanks.
Yeah, so basically here we need to consider the compliance as a fundamental way to make sure that we adopt what was required, but compliance is just a piece of the cake. Of course, we need to consider also best practices, not even standardized, and so act by principles, not only by regulations. And then, of course, we need to consider the other pieces, uh, meaning that the edge device needs to be clearly, as we said repeatedly, it needs to be identified and authenticated on the connection. The firmware must be secure and must be updatable at ease. And the same for the data storage. The data should be in a secure vault, not easily accessible physically or wirelessly. We need to provide a life cycle management for also for the tiniest device in the IoT network. Then, of course, we have the network connectivity. We have issues. We know that with the old GSM networks, so that the jamming was a common practice to create big outages or denial of services that could prevent also emergency responses. And speaking about emergency responses, we know that there are several solutions that provide dedicated networks for first responders, let's say in a case of a crisis. And this also means involving and adopting the best practices in the cloud and in the application layer. This means that you need to make sure that security is always present in your systems and deployments. But security is a function of time, so you need to guarantee it, and it decays, so you need to maintain the systems. And for this, you need long-lasting, trustful partners in building your smart city. And Telit and Digi are trustful and long-lasting partners in your deployments.
Just a quick word as we work to close. If you have any questions, concerns, you got a project of interest, my contact is there, stevemazer@digi.com. But also you can go on our website and enter to contact us or any. There's other ways as well. There's an online chat, for example.
Great. Thank you so much, Enrico and Steve, for that really great information. Audience, before we get to the questions, I am going to drop a poll on your screen. If you'd like to have one of our experts contact you, if you have specific questions that you'd like to have addressed one-on-one, please respond here on the poll and we'll be sure to have someone reach out to you. As we said, we do have time for some questions. There's still time to ask a question, so please feel free to submit using that box, and we will do our best to cover it in the short time that we've got left here. I'm just going to dive right in. The first question we have, utilities usually have longer tender bid cycles with huge quantities and multi-vendor approach. How can governments guarantee that utilities are future-proof?
Oh, I can take this, Steve, if you agree. Basically, the point is that when you go with tenders, they are really long, they're long-lasting, they have lots of requirements, and they're really complex ones. The point, based on our experience in Telit Cinterion, is that sometimes you need to provide something more than what is just requested, and the best thing to do is to think about the solution and to make sure that it's future-proof. To make sure that it's future-proof, you need to adopt the proper standards, not going into specific proprietary solutions or applications that can actually block any possibility to update and to improve to transition smoothly to a different technology or a different application or different security requirements. Because as I said, security is a factor of time and it's going to change. So the important thing is that we use standards, and X509 certificates, as Steve mentioned in his slides, is one of the best ways to guarantee that the device has an identity, just to make a simple example.
Great, thanks, Enrico. Next question I have here, a pretty interesting one actually. If IoT devices are run in a secure private network, how is security maintained when connected applications reside in a public cloud?
I can take that, Enrico. That's a good question. I think it's overlooked. People don't know that that's a question. And as you might go to great lengths to ensure all your devices are on a private network with private IP addresses and you're safe from any sort of public access. Yet, of course, the benefits of the cloud are there. How do you then access applications in the cloud instead of hosting them on your own data center, for example? And actually, the providers, as most of us know, AWS, Google, and Microsoft all have virtual private clouds that even though your application resides in a public cloud, they provide a safe containerized area. And then from there, you access it via a VPN from your facility to that virtual private cloud, and they set you up with your own private address space. So all your devices stay off the public internet, and of course, the public internet can't access these systems. So that's a great way to keep your OT system secure.
Great, thanks, Steve. Next question. We hear so much about certificates for authentication. Why can't a hacker just create a phony certificate and gain unauthorized access?
Sure, I can take this one as well. As we talked a bit about certificates, they're the best way for authentication, but you'll always wonder, right, what's in a certificate? Why couldn't someone just create a phony one? And the reason is of the cryptographic technology on one hand, and the other is also the certificate authorities. These are established companies that provide a vetting, right? When an organization wants a certificate, they ensure that that's a valid organization. They create the certificate. The certificate then is assigned to the company, and part of a certificate is actually, it's very interesting. There's a private key and there's a public key. And if you ever, and then that trusted certificate, if you were to access their website, you authorize that in your laptop, or your IT manager does. And then if there's ever a need to validate that, you can request a certificate validation. And what happens is the entity will send you a message, right, that's encrypted with its private key, and you can use then the public key, which is available to anyone, to decrypt it, and immediately you'll see that it is actually that entity. The way the technology works is quite remarkable.
Wow, yeah, very interesting. I didn't know that. Next question I have, it seems that the security requirements are high barriers for small enterprises wanting to enter smart city business. What are your thoughts about it?
I can take this for some, well, one reason specifically, because now we just delivered, rolled out a device that works with AWS Express Link, and this is a perfect example of how you can simplify all the requirements that you need to ensure a secure connection to AWS IoT through a device. Basically, this device comes pre-provisioned with a certificate, with an X509 certificate, and they have the connection secure through TLS 1.2, and the device is has a secure vault, so the data is stored securely and cannot be accessed and cannot be tampered. So this is an example of how Telit Cinterion can accelerate the business for customers that are not really into the IoT security requirements and implementation of them. And so basically we're opening up a space also for smaller enterprises to come into the smart city business.
Great. Next question. And Steve, I'm going to guess this one is for you since you touched on this. Why is FIPS 140 important? Isn't OpenSSL just as secure?
Yeah, good question. Some of you may know that the FIPS object module used by most entities, it actually came from OpenSSL, and OpenSSL is regularly updated, whereas as FIPS, you go through a validation process, quite difficult to make changes. But why is it important there is because FIPS is validated. You can't change a single letter of code, not even a line of code. What is produced there as far as the hash functions and encryption and authentication is absolutely ensured because those modules are validated and unchangeable. OpenSSL as secure, although what's the challenge there is that you don't know, right, if a developer has made modifications to the OpenSSL library when they implemented it in their device, for example. It's not validated. It's a broader scope of cryptography than FIPS, and it's a very good package. Everybody uses that as well, but it's not validated, so you can't be sure.
Great, thank you. We'll take a couple more questions here. Got a few more minutes. Next question I have, what is Telit's point of view in cellular connectivity provisioning?
Oh, that is nice. I'm going to take it, of course. Now, the point is that we haven't touched deeply on this, but Telit Cinterion is providing connectivity services, connectivity activation and connectivity lifecycle management. So basically, we provide multi-AMC connectivity, and we also provide the possibility to manage this connectivity remotely. So this means that with us, you're really going to have a long-lasting way of managing the data plans and the connectivity by all means. So be sure to contact us to have a wider and a deeper description, overview of what we can do for you.
Thanks, Enrico. Steve, I'm going to throw one last question to you before we wrap up here. How is 5G technology contributing to IoT?
Sure. Thanks, Amanda, and the questioner. The 5G, as we all know, gives you faster bandwidth, but it's much more than that. They've also extended the address space tremendously in it. So there's many more devices that can be connected to a 5G network than a 4G network. Also, the latency has significantly reduced from LTE, so you get a faster time on it. And 5G continues to evolve. What you'll see soon is something called sidelink or point-to-point, where a 5G device can actually talk to another 5G device. You don't have to go through the tower. That's going to open up a whole set of new applications in IoT, and we'll take advantage of that, of course, when the time comes. It'll be a nice new feature in networking.
Great, thank you. Guys, I believe that's all the time that we have got for today. Audience, please be sure to check your inboxes in the coming days for that replay link. Again, there's lots of resources here in that resources section that you can check out. Enrico, Steve, thank you so much for the great information today. A big thanks to Digi for their support on this webinar. And thank you everybody who joined us. Have a great one.